In this presentation, we're going to look at curve sketching. So this is the function that we're going to work with. F of x equals 1 over x minus 3. Now in this, what we are told also is that x cannot equal to 3. That's quite important. Because if we do let x equal to 3, what we get is this, f of 3 equal to 1 over 3 minus 3, that is 1 over 0. Not allowed, not defined. Okay, so x is not equal to 3. Okay, so far so good. Now the first questions we're asked are essentially, in this case, find the y-intercept, and are there any x-intercepts? So first off, let's look at the first one there, y-intercept. And what we do is, actually I was going to sort of write that out. Essentially what we do here is let x equal to 0 and solve for y. Okay, so of f of 0 equals 1 over 0 minus 3, that is equal to minus 1/3, so that the y-intercept is therefore 0 and minus 1/3. So we'll sort of save that one. That's the first one of our points we know from this curve. Now, are there any x-intercepts? Well, just in general, x-intercepts, just in general what we do here is we would let y equal to 0. Okay, now, but there's a problem here. So if 0 equals 1 over x minus 3. Now, essentially we can't solve that because essentially 1 over x minus 3 can never equal to 0. Essentially the problem here is that for this to be equal to 0, the numerator has to be equal to 0. So this is not equal to 0. So if that was some sort of fraction or some sort of expression in x, that might equal to 0, but because we have a constant term there, 1 is, it can't equal to 0 essentially. Okay, so there are no x-intercepts because we have a fraction there where a constant term is in the numerator. So if there's a constant term there in the numerator, it just can't equal 0. Simple as that. So essentially, again, just to be clear about that, actually, just make this absolutely clear. If a over b is equal to 0, some fraction, that means a has to be equal to 0. It's the only way it could work out. Okay, and that's not the case here. The case here, it is equal to 1. Okay, so anyway, there is, in general, what you do is let y equal to 0 and solve for x, and in this case can't do that. So that's why there are no. Are there any x-intercepts? No. Okay. So what we're going to do now is actually just sketch some points here. Essentially, this is a straightforward enough exercise. Essentially, what I'm going to do here, I actually already put one in here. 0 and 0 minus 1/3. So if, let's just remind ourselves, it's 1 over x minus 3. Also, you might notice that I don't have x equal to 3 down here. I skip from 2 to 4. Okay. So minus 3, so 1 over minus 3 minus 3, that's minus 1/6. So minus 3 minus 1/6. Minus 2, that is minus 2 minus 3, so that is minus 1/5. Okay. So minus 1 over 5, that's minus 1/4. So those are the various points, minus 1/3. 1, so 1 over 1 minus 3, that's at minus 1/2. So we have 1 and minus 1/2. That's 1 over 2 minus 3, that's 1 over minus 1, so that's minus 1. So that's 2 and minus 1. Keep going. 1 over 4 minus 3, that's 1, so we have 4, 1, 5, that's 1/2, so 5 and 1/2, and so on. You get the idea there. So those are just a couple of points there. that we can use to sort of get an idea of how this looks. So what I'm going to do is actually just quickly sketch it out. Okay, so what we have there so far. Okay, so essentially just looking at a couple of points, -3, -2, -1, 0, 1, 2, 3. Okay, we don't go to 3, 4, 5. So essentially what happens is it seems to go down like this. It goes to -1/3, and then down like that. Okay, I haven't really depicted it very well, but that's just essentially. I'll just see what I mean. So it'll be -1/6 to -1/5, minus a half, -1/3, -1, or minus and so on. So those are just a couple of the points we picked out. Okay, and over here we have 4 and 1, a half, and so on. So it seems to have another. I'll actually, do you know what I'll do? I'll just put that in blue over there as well. So, and so on. So far so good. Now, essentially what I've done there is just picked out some points, just to sort of get a sense of how it might look. Okay. So what I'm going to do now is I'm going to start to see. There's a big question here, and it's to do with asymptotes. Okay, so the first thing, asymptotes. So the vertical asymptote, so of f of x, essentially get the denominator and solve. Let it equal to 0. And solve for x. That's how you get the vertical asymptote. Okay, so in this case, our function is f of x equals 1 over x minus 3. So essentially what we're going to do is get the denominator, x minus 3, let it equal to 0, and therefore x is equal to 3. So that is our vertical asymptote. Okay, so what I'm going to do is go back here and draw in our vertical asymptote. This isn't really a great sketch, but essentially this is the x equal to 3. Okay, so what happens here is we have an asymptote going down here. An asymptote is a line that it gets closer and closer to but never actually crosses. Okay, so that is the idea of an asymptote. Just going to draw this. Oh, there we go. So it's a bit too big. I'm just trying to draw this in black, the x-axis. Make it a little bit clearer there. Okay. Now, so this is the vertical asymptote. Okay. Now, is there a horizontal asymptote? So, they don't always exist, by the way. So, limit of f of x as x approaches infinity. Okay. So, the limit as x approaches infinity of 1 over x minus 3. Okay. Essentially, this is one situation where we sort of just divide by the highest term. So, for example, 1 or the highest power, 1 over x, x divided by x, minus 3 divided by x. That's sort of essentially just very straightforward limit. In this case, what we had there is 1 over infinity over 1 minus 3 over infinity. A constant over infinity is just 0. So what we have is 0 over 1 minus 0. So 0. So our horizontal asymptote is simply 0. So y is equal to 0. Okay, is the answer here. So let's just go back here. This is our. I'm just going to start drawing there. It's just. This is actually just supposed to be the x-axis. Y is equal to 0. So that is the horizontal asymptote. That dotted line there. It's actually y is equal to 0. This is x is equal to 3. Okay. Now we've just drawn in some of the points there as well. Just pick them out and so on. Okay.